Hi everyone, Brian back again, and today's video is about programming tank control on your V5 robots. This time we'll be programming in Vex C++ and C++ Pro using Vex Coding Studio. The key difference in these two languages is the configuration process, but everything else is basically the same. Before we get started, I want to clarify that I will be programming a V5 clawbot kit, so my configuration process may differ from yours, but the concept is the same. First, I'm going to walk you through the configuration process for both Vex C++ and C++ Pro, since everything else is identical after that. If you're only interested in C++, there's a timestamp on the screen and in the comments. On this welcome screen, we select Vex C++ and then click Choose. We are brought straight to the configuration screen, or the robot view, and you'll notice it's identical to the modkit robot view, and that all you do is drag in the devices you'll need for your program. Now all we'll need here is the controller and two motors. And to make our code easier to read, we're going to name them accordingly. So this one will be left motor, and this one will be right motor. We're also going to configure our ports. Now with these two motors, as I've mentioned in previous videos, if they are facing a certain way, they might be reversed. One might need to be changed so that the robot, instead of turning, will drive straight when you tell it to. So I'm just going to reverse my motor. You click settings and then click reverse. That would be all for Vex C++ configuration. Now let's get started with configuring our robot in C++ Pro. Now we're going to jump back to this welcome screen, and this time select C++ Pro and then click Choose. And when it loads, you'll notice that it brings us to this tab main.cpp, but we actually want to start off in the robot-config.h tab, so we'll click on that. And we'll be brought to this, which just says Vex : brain, and then brain with a semicolon at the end. Now, we will need more than a brain. We'll need a controller and two motors. And to drag those in, there's a nice panel on the left in alphabetical order, and you'll see controllers here. And we'll drag the first one in. And then scroll down and look for motor, and we'll drag that first one in as well. Now these gray names that just repeat the name before them, like brain, those will be the actual names of the objects. And if you need to understand more about objects and the way that this is written, let's go to the idea dome for that. Definitely not a ripoff of Thought Bubble. So imagine Vex as a folder. We've seen this reference before in the robot-config.h file with the double colons. Well, this folder contains utilities and settings for all the devices that you'd have on your robot. These can be accessed using the side panel present by default in Vex Coding Studio. Each of the devices, like the controller, brain, and motor, have their own folder inside of Vex that define what they are. To help you understand this, let's use animals. The animal class has its subcategories, just like Vex, that specify different types of objects and their capabilities, so the motor class can be compared to the bird class. While they may seem different by appearance, they're actually alike in many ways. They can both exist in different forms, like the motors having 3 types of gear cartridges for torque and speed. But each form inherits the same data, which can come in the form of methods. Methods can be thought of as actions that are available to the object. For the motor, this would mean spin, stop, or rotate. Do birds have methods? Well, yeah, birds can fly and emit noises like quacking, and some even talking and singing.
Or attacking if you get on their bad side.
Conclusion. When you use a double colon in between Vex and an object, like motor, you are navigating from the Vex folder to the motor folder, just like you do with a regular file path. When we follow this up with a name, like left motor, we are creating a new motor that now has access to all the previously mentioned methods, and also sensory settings. Okay, so now that we understand that, we'll realize that these are really default names, and also we're missing a motor, so let's add another one of those in. Now, we're going to name our motors left motor and right motor, and also we're going to change our port numbers if they need changing. And that is the basic configuration for C++. Now, if your robot is set up in a weird way or your motors are switched, you may need to reverse one of them to make sure they don't turn when you ask it to go straight. So all you do is add a parameter in these parentheses, and whichever motor needs to be reversed, you just type comma and then true. And you'll see it highlights blue because it's an accepted and valid parameter. And this basically just reverses the robot. So from here, we're going to jump straight into the main.cpp tab. But before we start adding code to the tank drive, I stress that you add a name or create a name for your program. All right, so the first thing we're going to add is a while loop. Give some space. And this while loop is going to tell the program how long we want the actual code inside the brackets to run. And in here, we're going to add true. Now, the reason we add true here is so this loop will be infinite, which means that the loop will not stop and the program will constantly check this value. And this is very good for our program because we want to constantly have control over it, and we don't necessarily want to stop having control at any moment. So now we're going to set up our motors in here and type in the motor names. So we got left motor, and then we have our right motor. Now, with these motors, like I explained earlier, they're objects, and objects have certain methods or things that they're all able to do. And if you look on this side of your screen in the actions, you'll see all the actions available to the motor. And we're going to utilize this spin method, and it gives you the syntax, but I'm just going to type it right here. If you hold down the control button, you can type on multiple places in your code, and that's really helpful, I find. So spin, and then we're going to access those Vex folders. So Vex, and then we're going to find our direction type so we can define it. And we're going to use FWD because we want them to go forward on command. And we're going to map their value, which is the next parameter that goes in, to our controller. And later I'm going to give them different axes, but for now we're going to set them to 3. I forgot a dot. And then axis 3 value. And since this is a method, we're going to add those parentheses, and that'll be our second parameter. And now onto our third, which is going to explain how we're measuring this. And we are going to measure in percent units. And semicolons after every single line. And basically what this is doing is setting the motor power to the and then blank joystick. Alright, and if you're wondering what these slashes are right here, these backslashes, really what they're showing is that we're ignoring everything behind them, and in programming language we call these comments. So these will help whenever you're reading back over your code and wondering what in the world those lines of codes mean. Like I said, we don't want them both controlled by the axis 3. We actually want this one to be controlled by the 2, and if you look on your controller you'll see numbers around the joysticks to show the axis, and we only want y-axis of the joysticks for tank drive, and specifically we want axis 3 for the left side since it's on the left, and axis 2 for the right side since it's on the right. And this is driver control for a 2-wheel drive robot. Thank you guys for watching this video. If there were any gray areas, mistakes, or just things that I missed entirely, feel free to leave them down in the comment below. If you have any questions, suggestions on programming languages in Vex, just leave those down below as well, and I'll be sure to take a look at them. And I'll answer them whether it be a short response or a video. Make sure to like and subscribe, and see ya.